And welcome to the video. I'm pretty excited about this video. I've been working on this project for a few weeks. When I first started my website and my YouTube channel, I really wanted to explore my passion, soccer. Use programming to gain some insights, some data insights into the game, either stuff that prove some things I'd heard or disprove or whatnot. I knew doing this that finding data was going to be hard because I knew that essentially was what gave teams a competitive edge, and they're going to keep that a secret. So finding the data was going to be hard, but what I did not realize is the actual software wasn't going to be as open source as I'm used to as a programmer. So as I'm going along, trying to find different packages to analyze data, I realized, hey, why not create your own? And that's exactly what I've done. I've created a Python package that is free for people to use. It's pretty basic right now. It is a growing project. I really love doing it. I'm gonna push this to the limit that I can, so that people have the ability to analyze their own data and gain insights and gain knowledge, because knowledge is power, and we the people should have it. So let me go ahead and jump in here. If you like to read more, I do have my website that goes through exactly what this video does. I will post all of the sites actually in the description here, but this one as well. So this one is a real short article, shows you what you can do with the data, as well as documentation for the Python package. I have that online for free as well. So if you'd like to, go ahead and jump down there, but don't leave without liking or subscribing. All right, let's jump into the actual programming part of this, and I'm going to walk through how to install it and how to create your own heat map and create your own sprint map. So yeah, so we're going to come over here to our Python package. I'm going to come down here to my terminal, and I'm going to go ahead and install that. Of course, I've already got it installed on my computer, because why wouldn't I? But, just want to go ahead and illustrate that for you a little bit. And then the next part, we are actually going to start writing our code. Let me comment some of this out so it's easier to follow along. Okay, so some basic imports that you're going to need are pandas. I am reading my data in as a CSV file, and I'm importing it as pandas just because that's how I know how to do it. And then I'll be converting it into a NumPy array. NumPy array is what is necessary to pass to these as the data currently for the way the program is written. In later versions, soon, data frames can be passed, and it make it a lot easier. And you paste whatever kind of data you want, just paste it in there. Essentially, has to be x and y coordinates for a field. And somewhere in the not too distant future, I've got an actual program that still needs testing. You'll be able to pass in latitude and longitude. It'll do some transformations and some really cool stuff to create the x and y values for you. But for right now, we need the 2D array, x and y values in the NumPy array. And finally, we do need a pyplot because what I'm returning to you is a pyplot. So you're going to need to go ahead and import that so that you can then manipulate the figure however you want. I've given you the option to manipulate it afterwards and not just go ahead and save it for you. But that is what we're going to do here. You could theoretically do whatever you want to after you get it back. All right, let's come down here and check out the data. Like I said, I'm importing the CSV. My data actually has a lot of different players, so I'm going to go ahead and pick player number 5. And then I'm going to grab his and x and y positions, and then I'm going to save that as an NumPy array. All right, I'm not going to go into too much detail about that, but that is how I am getting my data in there so you can see. The next thing you'll need to do is to actually come down and import the package you just installed. And I want to go ahead and just talk about right here why there's so many different, things to import is because this package is meant to grow. Right now, we're doing some visualization stuff and graphs of a heat map. Like I've mentioned, there are going to be later iterations. One of the next things that's going to be coming up is an actual video. So you'll be able to put in your x and y positions, and it's going to create a video of time space. You might want like 7th minute to the 15th minute of a certain player's movements, and you're going to be able to do that. And then later iterations, we're actually going to include some mathematical models in there that you can apply to uh, your players' positions and event data. So that's why it's separated like that. Just a little note. All right, let's go ahead and get into creating of the heat map. All right, so I try to make this as easy as possible. The only thing you have to pass is the data. Right now, that's a 2D NumPy array. Later iterations you will allow for a little bit more flexibility, but it's the only thing that you have to pass. So we create our heat map. We pass the data as the dat that we had. All right, now we've got our heat map object. So you can actually come in here and pass some other stuff, and later iterations will allow for a lot more things we pass. But right now, colors, you could pass something like magma. That is actually the default magma. I've got it in documentation, the different kind of color schemes that you can pass. So you can have a look at that later. But right now, I did want to show you that set colors is something we can call on there to change it later on if that's what you want to do. All right, so yeah, I've changed it to Inferno to give us a little different look. And then that last thing we're going to have to do is create heat map plot. So go ahead and create that. That's going to return your plot object. And I'm going to take that and I'm going to save it. And I'm going to save it as something unique here. Oh. All right, so Toratil. Yeah, spelling is not my strong suit, but you know what? I'm going to leave that just because it is actually pretty unique and we'll be able to find it easily. All right, so let's come in and write. Let's go ahead. And what did I name this to do? Cool. We are in the right directory. That always makes me happy. Go ahead and run it, see if we get any errors. And we are good. Cool. So we have created our heat map and saved it as, yep, see it right here, Toratil. Let's open that up. Fantastic. So let's take a look at this heat map. I actually don't know anything about this player number 5, but it does look like I'm guessing he's a center back. I do know that this particular team was pushed back in their own half a lot. They were on defense a lot during the first half, and he did not make it very far up there. Otherwise, you could guess that maybe he was, I'm sorry, not center back, center midfield. Otherwise, you'd be able to guess he was a center back. But I believe this is a center midfield player. It does look, he did spend quite a bit of time in his own box defending corners. Anyways, so yeah, that's a really cool thing to look, say, okay, wow, my guys really were pushed back during the game, and we really want our center midfield really pulling back in between in this area to receive the ball or something, whatever you want to do to analyze it, but this gives you a great visual representation. I believe I've got someone else. Yep, I believe I've got a right back saved in here. So let's take a look at one of the right backs. You can see that his data is quite different. He spent a lot of time still in his own house, so that probably supports our theory that they were pushed back a lot. In this area, this team were crossing a lot of balls in this direction, I do remember, into this area, so he spent a lot of time sort of right here running back. Yeah, but so this is the different looks that you can get with different players. All right, awesome. On to the next part. Next part, we want to come down here. We want to do same thing we did for the import above. We are, go ahead and comment this out so there's no conflicts. We're importing the Toto fcpy.visualization.graph, and we're taking the sprint map object from that. And I am going to keep player number 5. Yeah, it's already up there. So we can compare him, and this is already data right there. It's redundant. All right, so this one's just as simple. Put your data in there. Right now, this doesn't have any changes to data, changes like colors or different things you can do. It's just the basic sprint map. Like I said, later iterations, but we're not there yet. So all I've done is pass my data to my sprint map, and we created that object, and then we want to create sprint map plot, and then let's come down here and actually save it. tutorial sprint. Wow, look at me type. There we go. You know, I haven't had to spell in a long time because the computer does it for me. So let's go ahead and run this. What have I done here? Unexpected indent. Oh, Python. Thank you. Fidgety. Okay, look, no errors. Hey, there we go. Tutorial correctly spelled. Sprint map. Let's open this one up. And this is for the same player. Awesome. So, looks like in the first half, he only completed 2 sprints. The default on this is 6.7 meters per second. That was based upon my own research of what a sprint was. Later iterations, I want to get the user to have as much control over that as possible. So sprint could be 5 meters per second or 10 meters per second. Heaven forbid, I can't run that fast, but if that's what you want to measure your players by, you're going to be able to change that. But currently, the default 6.7. The arrows actually will point the direction the player is turning or running. So we can see there's a slight curve right here. These arrows, he's probably already sort of given a little bit of a turn. That's the way he's facing. So the sprint looks like it goes right through here. The sprint is right here to right here. This makes sense that this is our center midfield player. He's operating in the same place we saw the heat map. This sprint is 1 second, so anytime we go from one triangle to the other, that's a second. This sprint is 2 seconds. Makes sense because I think in soccer, your sprints are like 1 second to 5 seconds are sort of the average amount of sprints. And a center midfield player probably isn't making as many sprints when they're pushed back. So, it's only 2 sprints, but it kind of makes sense for the data we have. So, yeah. Let's actually, you know what, I'm going to go look at another sprint map I have saved. And I'm going to guess this is for the right back as well. I don't know that for sure, but that kind of makes sense for what we see. Now, there's a lot more sprints. They're all very short. This one looks like he was running fast enough, didn't quite run fast enough in here to be considered a sprint, but continues through here. And this one, he's running back right here as well. This makes sense. If you remember, they were crossing balls in him to right here in this part of the field, and then trying to run in and take shots. So it looks like he did complete some sprints sort of back to this corner to defend those balls in there. A lot of his sprints are actually absolutely running back, aren't they? So he was doing a lot of defending. Anyways, yeah, so that is the video. I hope this has been helpful. Like I said, I'll post all the links at the bottom. Any questions, please, comment here on YouTube and I'll answer. I got nothing else to do right now. I'd be happy to talk soccer at any point in time. Any ideas for what you guys would like in the future? I really want to hear that because I'm building it based upon what I want. And if people are going to be using this, I'd love to hear what they want as well. And so always go check the website, subscribe to YouTube. Let me know what you think. Awesome. Thanks for tuning in, and I'll see you soon.